Okay, so this is something new, price and demand relationship. So think about that. Price is how much you sell a product, and demand is how much are consumed, how much are bought in the market. Okay, so the first thing about demand and price is demand D changes according to the price P. Okay, this is easy to understand. Think about selling your bread. We're still running a bread shop here, okay? Selling a bread. So if your bread, one piece of a bread is cheaper, right? Then maybe there are more customers to buy it because it's cheaper. But of course, you have to maintain the quality. That's the assumption. So under the same quality, if your price is cheaper to sell a bread, then you're going to sell more breads per day or per month, right? That's very easy to understand. So the demand on the market, how many breads are sold, how many breads are bought by customers, that demand is changing according to the price, okay? And then think about this question. If a product sells at a higher price, then fewer or more people will buy it. Okay, so if you're selling at a higher price, do you think more people will buy it or fewer? I think it's fewer. Because it's more expensive, then people wouldn't spend that much at the same product. They might choose another cheaper one, right? So the demand is going to be lower. And second, if a product sells at a lower price, then do you think more or fewer people will buy it? If it's cheaper with the same quality, of course, more people will buy it, right? So these two situations are very easy to understand. We see it every day on the market. So now what conclusion we can get is the relationship between price and demand. Here is the relationship, which is very important, okay? So I'll give it a star. If price increases, demand will decrease, right? So if you sell it more expensive at a higher price, the P increases, right? So fewer people will buy it, which means there will be lower demand. And then if price decreases, it's cheaper, something is cheaper, then demand will increase. That's very easy to understand. If it's cheaper, more people buy it and more you sell, right? So demand will increase. Well, this is the conclusion of the relationship between price and demand. So what if you sketch the relationship using an X and Y coordinate system? You put it on the X and Y chart, okay? So you use X-axis as demand D, and you use the Y-axis as price P. Just imagine what kind of line you end up with. Okay, so this is gonna be the line. Is it the same as what you think? So let's say the D is the X-axis, that's the demand. And the Y-axis is price P, okay? So what we just use our common sense, like if the price is higher, right? Like this point, maybe the price is 1,000, then you get this demand. Like that's the number of breads you sell or number of products you sell. maybe that number is 20, okay? 20 units of product. And if we also know if the price is cheaper, like somewhere here, the price might be just 200 US dollars, and then of course you will get more demand, okay? You sell more, maybe that number will be 100, okay? So you end up with a line going down, okay? Not going up, it's going down, which means when price increase, demand decrease, right? And when price decrease, demand increases. That's what the line going down tells you. And then if you want to write the function of this line, this is going to be the function you can use. So this function or this formula, it describes a line like this. So P is the price. And A and B are just two constant. Okay? And the D is demand. Okay, so for different types of products, you're going to have different types of this type of line, but they're all going downward. And the difference is they have different A and different B's to describe the detailed relationship. But all of them can be written as this abstract form. Okay, so maybe you think this is too abstract, but let's just take a look at a real example. Okay, so keep this in mind. Our relationship between price and demand is always a line going down, and a general formula for this relationship is written as P equals to A minus BD. Okay, and depends on different types of products. The A and the B could be different. Okay, P is just a dependent variable. Okay, and the D is independent variable. Okay, now the example, what it said. It says a company produces an electronic timing switch that is used in consumer and the commercial products. Okay, so they are producing electronic timing switch. That's the product. And the fixed cost, CF, is $73,000 per month. Okay, that's one variable. And the variable cost, C lowercase v. Look at this. This is lowercase v, which means it's a variable cost per unit, right? It's 83 per unit. Okay, that's another variable. The selling price per unit is written as P equals to $180 minus 0.02 times D. Okay, so that's the relationship between P and D. Okay, so based on this equation, what values you can get or what conditions you can get. Okay, so first, in this statement, we already know that CF is what? Is 73,000 per month. So every month your fixed cost is 73 grams. And you also know C lowercase v is $83 per unit. Okay, so this is the second variable or condition you can have. And the third thing is it tells you that for selling the electronic timing switch, this type of product, a specific relationship between P and D is 180 minus 0.02 times D. Okay, so what I want you to do here is compare these two formulas. Okay, compare these two formulas. So P is P, right? And D is D. That's the two same identical variables. Okay, now can you tell me what is A and what is B? Just compare these two formulas. Okay, so P equals to A minus BD, and the specific relationship given is P equals to 180 minus 0.02D. So seems like this 180 is A. Okay, and this 0.02 is B. Do you think so? If you compare these two, right? Because we said that the P is A minus BD is a general form. And for different types of products, you're going to have different A and different B to describe the specific relationship between P and D, right? Which means for a specific product, you're going to have A as a number, B as a number. And how do you know what number it is? This is how you know that. You compare the general formula and you to the specific formula you're given. Okay, so what you can write here is A is 180 and B is 0.02. Be careful, there's no minus, no negative symbol. No negative sign before the 0.02. B is a positive number. Okay, don't include the negative sign. Don't include this negative sign. Okay, don't include that. Do not include this negative sign in the value of B. So B is a positive number. Okay, this is very important. A lot of students struggle with this. Okay, so your B is gonna be a positive number. Please do not include that negative sign before it. Okay.